Business. Questions from homeworks. At this point, we've assigned worksheets 4 and 5. Does anybody have questions from homeworks or Delta Math? I guess you could ask questions about that too if you have issues there. Anyone? Questions from homeworks? Okay then, here we go. Today, we're going to be talking about graphing the sine and cosine functions. So, scariest 3 words in trigonometry. Remember from geometry, those are the 3 scary words, because you have to remember something. You guys talked about transformations. Sound familiar?
Yes.
4 types.
Up and down.
That's a translation, up and down, or left and right. What else?
That's as far as I got.
Yeah, transformations. You can have dilation, so stretching, like expanding or contracting, right? Reflection, flipping, and then rotation, so like spinning or whatever. Everybody okay? You remember those?
Yeah, I do. Do you have a charger?
Like the kind of car?
No.
I drive a Jeep.
I do need a charger for the car.
As a joke. Haha. So of those transformations, we only care about 3 of them. The one we won't deal with is the rotation. In your high school math class, all of them, any of them, no one's going to ask you to rotate a function via transformation. Because let's say we have a sine or cosine function that looks like this. If you pick it and turn it like this, what's the problem with something that goes like this? It's what? It's annoying. There's a bigger problem than that. It's not a function anymore. Why not? It fails a vertical line test, right? Not a function. We're not going to deal with anything in your high school classes where we take something that is a function, transform it into something that's not. Okay? So the only things we'll be considering are reflections, translations, dilation. So moving things left to right, up and down, stretching them out or shrinking them down, or flipping them over, like the X or Y axis. Sound good? Good. So this behavior, the behavior of these transformations is actually predictable. We can look at the equation and be able to see the transformation just by looking at the equation. So just by using that A, C, H, and K, we can predict our transformation or transformations. Yes, Lucy. Sure. So remember, we have this. right? That's our general form. Just looking at that and reading the values for A, C, H, and K, I claim that we can describe the transformation occurring. So far, so good? Okay, well, let's give you the criteria on how we use that. We'll start with the C's. If C is less than 0, so negative, we have a reflection across the y-axis. And if C is positive, we don't have any reflection on the y-axis. So far, so good? But C actually does something else also. So the magnitude of C also matters to us. So if that magnitude of C is bigger than 1, we have a horizontal stretch by a factor of C. And if that magnitude of C is less than 1, we're going to have a horizontal shrink by a factor of C. Can somebody give me an example of a number whose absolute value is less than 1? .5. Thank you, Jacob. That'll do. Right? Negative 0.3. 5/6. Negative 8/9. Those are all examples of numbers whose absolute value is less than 1, right? Everybody's cool? Sometimes kids will think that there's nothing there. There's lots of numbers there still. All those numbers between -1 and +1, not including 0. All right. Notice there's 2 numbers that are left unaddressed. 0. Can C actually ever equal 0? Why not? Tia, you shook your head. So look at the equation. What if C were 0? It's undefined, right? 1 over 0 is not a math problem we know how to do, right? That's undefined. So C can't ever equal 0, so we don't have to worry about that. But what about C equals 1? If the absolute value of C is 1, that's not listed anywhere in my criteria either. Well, it just means that there's no dilation happening if the absolute value of C is 1, right? You could still have a reflection if C is -1. That can still cause the reflection, but then there's no dilation in addition. Everybody's okay with that? So if you want to write that in, that absolute value C equals 1 is no dilation, you could do that. I usually don't bother, but if you're a completist, you're welcome to do that. Next thing we'll look at is the A's. The A's kind of do a similar thing, but this time you're looking at the up and down actions. So again, we're going to have a reflection this time across the x-axis. And the dilations are going to be vertical stretches and shrinks. So, just as a reminder, the word vertical, when you write it on a sheet of paper, NCAL, I frequently see students end vertical with ICLE. Now, I'm not going to mark it wrong if you misspell a word. It's math class. Come on, Mr. Kulik. But I am going to look at your paper and shake my head and go, oh, dear. Oh, dear. And I have enough oh, dear moments in my life without, like, you guys adding to that. So if we can try to spell vertical correctly, I appreciate it. Just doing me a solid. So I'm not looking at my paper and go, oh, the future of America.
Right.
Ay, ay, ay. Okay. So we've covered A's and C's. We still have to talk about H and K. Well, H greater than 0 is a shift, a translation to the right, H units. And if it's negative, it's going to go left, the magnitude of H units. Mr. Kulik, is that a typo? You wrote one H with an absolute value and the other H without it? Well, no, it's not a typo, right? If H is positive 3, it just means we go right 3 units. If H is negative 3, I don't want to say left negative 3 units. That doesn't make sense. A unit doesn't have a negative sign on it. Just say left 3 units. The negative part is implied by the left. You know what I mean, guys? Okay. And then if the H's do the left and rights, guess what the K's do? Up and down, guys. Up and down. Come on now. Now notice, nowhere on here do I account what happens at H equals 0 or K equals 0, right? Guess what happens at those? Nothing, right? It means there's no shift either left or right or up or down if it's H or K equaling 0 respectively. So this list of criteria, Mr. Kulik, is this something I have to memorize?
That would help.
It is, unless you put it on your half sheet. So if you're one of those people that makes notes along the way of like the stuff you want to put on your half sheet, I would make a note that like put this on my half sheet unless you want to memorize it, which you're welcome to. You might end up doing that on accident just from doing the homework. That happens to me sometimes. Or you just like memorize something and you didn't mean to do it because you just used it so many times. Fellas, like that's never happened to me. Sorry. Everybody feels okay? So far, so good? All right, let's do an example where we use this now. So describe the transformation for okay. So let's say we have the function y equals negative 2 cosine of 3x minus 9 minus 5. And we're asked to describe the transformation. First thing I want to do is figure out the values for a, c, h, and k. So usually what I like to do is write underneath my function, I'm going to write that general form. That's going to be like my blueprint for picking out my values for a, c, h, and k. My recommendation is that you find a, k, c, h in that order. So looking at this, who can tell me what the value for a is? Negative what? 2. That's correct, right? We just read it off the formula. How about what is k? Negative 5. Now, if I look at c and h, what do you notice about our function that's different than the general form? Well, there's something else going on that's more important than not a fraction piece, although that will come into play in a moment. Well, there is a c. Yeah, this is not factored, right? In the general form, I have the coefficient on the x pulled out front. That's not what I have in my problem. Did you guys see that? How it's different? So my first order of business is I want to get that 3x minus 9 into the factored form. So what do I have to factor off the 3x minus 9? 3. Okay. So what does the 3x become then when I factor the 3 off? X. What does the 9 become? 3. Everybody's cool? Just taking a greatest common factor out of there like we would in like algebra 1 or whatever? All right. So now, 1 over c, that's 3. So 1 over c is 3. What is c then? Not 3, not 1. If 1 over c is 3, what's just c? Nope.
1.
Nope.
2.
Nope. Nope.
1/3.
There it is. It's 1/3.
Why?
Because c and 1 over c are reciprocals, right? So if 1 over c is 3, the reciprocal of c is the reciprocal of 3. It's always going to be that way. C will always be the reciprocal to that coefficient on your x. Okay, always the reciprocal. Does everybody feel okay there? Okay. Who can tell me what the h is? I love the participation, though, that you guys are hammering out here. So the h is there. What is h? Not negative 3. Positive 3. Because notice there's already a subtraction symbol in our general formula, right?
Yes.
If I plug positive 3 in, I'll have x minus 3.
Question. would you get the same answer had you not taken out a 3 from the
No.
parentheses? So it's important that you simplify it.
Absolutely.
Okay.
If you wouldn't have factored the 3 out, you'd have said the h is 9. That's going to be wrong. You can get the wrong answers. Everybody's okay here? Now, will I have to do that kind of factoring every single problem every single time? No, right? If it's just like 2x in the parentheses and there's nothing added or subtracted to it, is there anything to factor? No. If it's x plus 3 in the parentheses and there's no coefficient on the x other than the 1, is there anything to factor? No. So c is just 1 and h is as it appears. Everybody's okay with that? So not always will you have to do this, but I want you to be looking to do this at first. That's why I'm giving you like this version of an example rather than like a really simple one. So we're just used to looking for the tricky case first. And if we don't see that, that's fine. Then it's easy. Let's not start with the, like the specific case and then try to generalize out. Let's start with the general and try to specify it. Like the worst case scenario you want to see first, so you know what to look for, rather than start with the easy one and be like, wait, why is this one so much worse? You know what I mean? Notice that the h will always be the opposite sign of what it appears, right? I had x minus 3, but h was positive 3. That'll always be the case also, that the h is always the opposite sign of what it looks like in the problem. So far, so good. All right, now that we have our values, let's go ahead and describe the transformation. So again, I'm going to do the stuff for C, A, H, K. That's the order that we look at. So since the C is positive, I know I have no reflection on the y-axis. But since the absolute value of C is less than 1, I have a horizontal shrink by a factor of 1/3. Because my A is negative, I am going to have a reflection across the x-axis. And because the magnitude of A is greater than 1, I'll have a vertical stretch by a factor of 2. Since my H is positive, I'm going to be going right and 3 units because H is 3. And because my K is negative, I'm going to be going down and it'll be 5 units because K is negative 5. So that's what like our description is going to look like. It's just a list where you've given the reason and then describe what's happening. Everybody's cool? Okay. Questions so far? It's all right? Pretty easy, right? The hardest part was getting the A, C, H, and K out of the formula, and then from there, it's just like, all I'm doing is looking this stuff off this list of what to do's. Not bad. All right. What we want to do next is look at how we get from the equation to the picture, right? How do I actually build a graph out of this? So, remember from geometry, oh, those 3 scary words again. When you're doing transformations, you start with these points from your pre-image, and then you transform them by adding or subtracting or multiplying or dividing to those points to create your transformed points. So the way that we'll do that, adding, subtracting, multiplying, dividing, is as follows. You're going to take the x-coordinate, multiply it by c and add h to it, and then take the y-coordinate, multiply it by a and add k to it. This map that we've done right here is something either you should memorize or put it on your half sheet, right? So again, if you're making notes while you're doing this about stuff that you need to put on your half sheet, I would highlight this thing as that's something I want to save. Yes, sir. Yeah, something like that. So far, so good?
Yes.
Okay. Now, so Mr. Kulik, I remember from geometry when we did this, you know, if I had a triangle and I was transforming it, I would just take the 3 points from my triangle, do my little transformation thing to them, and get my new points and plot those, right? That's kind of what we did. So if I'm transforming a sine or cosine graph, I start with just the regular graph of sine or cosine, and I'm going to take all those points and do this transformation to them. But Mr. Kulik, here's my problem. That graph of sine has infinitely many points on it. I can't transform infinitely many points, like be here all day. Not just all day, my entire life. Not just my entire life, but all of eternity trying to do this one problem. You didn't possibly mean that. Yeah, that's fair. What if I told you, yeah, don't worry about it. Let's just do one cycle. That'll be fine. And you're like, no, Mr. Kulik, a cycle still has infinitely many points. That doesn't solve my problem. So, okay, I see. I understand. What if I tell you we'll just take some of the points from the cycle, the important ones? Okay, now you have my attention. What are the important ones? The ones that either lie on the midline or at an extrema. Okay, great. What are those points then? So if I look at my sheet in my OneNote that says trig reference points, there they are for sine and cosine. So if it's a sine function, I'm going to use the points 0, 0, pi over 2, comma 1, pi 0, 3 pi over 2, comma negative 1, etc. And for cosine, I'll use that other set of points. So far, so good? Mr. Kulik, do I have to memorize these? No. Do I have to put them on my half sheet then? No.
Yes.
No.
No.
No. The way I'll set up the problems for you to do on the test is I'll give you these points and ask you to transform them. I'll give you that as the start. So it'll be something to be given to you on your paper. Everybody's okay? All right. All right. So let's do an example then. So let's say we have y equals -3 cosine of 2x plus pi over 4 minus 1. Okay, that looks like something I might have to graph at some point, sure. So we want to start by finding our values for a, c, h, and k. So usually before I do that, I write down the general form just kind of underneath my equation so that makes it easier for me to pick out those values that I need. Stop talking, please, girls. All right, so what is my value for a? -3. Very good. Any questions how we got that? What's my value for k then? -1. Any questions how I got that? Before I go looking for my c and my h, what do I have to remember to do? Well, it's factor is the word that you're looking for, but that's close enough. I'll take it. So what do I need to factor out of 2x plus pi over 4? 2, the coefficient on x, always. So when I factor that 2 out, what does 2x become? X. And when I factor 2 out of pi over 4, what do I get? Not pi over 2. Not 2 pi. So what I'm doing here is I'm doing pi over 4 divided by 2. Right? So what's half of a quarter? An eighth. So it should be pi over 8. Now, if you don't like that that explanation, think about it this way. Dividing by 2 is the same as multiplying by 1/2. So I could do pi over 4 times 1/2. Pi times 1 is pi. 4 times 2 is 8. Pi over 8. So if you don't like, what's half of a sixth or something, like
12.
It's a 12. Yeah, you got it. Everybody's okay? All right. What's my C then? Very good. The reciprocal of 2. And what's my H? Close. Negative pi over 8. It's always, the H is always the opposite sign of what it looks like in the equation. So far, so good. Yes, Coles. It's the reciprocal. It's the reciprocal. Right? Because the formula 2 is 1 over C. So regular C is just the reciprocal. All right. So let's go ahead and fill this into my formula. So I have CX plus H, AY plus K. So there's my map that I'm going to use. And since this is cosine, right, that's the problem, is a cosine problem. bugs in this room. We're going to be using those 5 points. Do you need to memorize those? No. Do you need to put them on your half sheet? No. Mr. Kulik, are you going to give those to me then? Yes. Okay. So what I'm going to do now is I'm just going to plug each of those x and y's into my formula that I wrote down above. You guys see what I'm doing? And plugging this stuff in. Yes, Tia. Yeah. What do you guys think? Is that okay so far? All I did was plug those x's and y's into the little formula that I wrote, right? No big deal. So now all I'm going to do is simplify things. So let's look at that first point. What's 1/2 times 0? What's 0 minus pi over 8? Okay, negative pi over 8 is my x coordinate then. What's negative 3 times 1? And negative 3 minus 1 then is negative 4. So that's my first point. So far, so good? Okay. Next one. What's 1/2 times pi over 2? Right, like just looking at that. Pi over 4. 1 times pi over 2 times 2. So pi over 4. What's pi over 4 minus pi over 8? Nope. Nope. Make a common denominator. 1/4 becomes 2 pi over 8. 2 pi over 8 minus 1 pi over 8 is
1 pi over 8.
1 pi over 8. Yes.
Are we gonna have to do this for every single question? Problem?
Yep.
All the points?
Yep. What? Sure. How many what will there be? When? Ever? In life? Infinitely many. On the test? A couple.
All
right, 3 times 0 minus 1 is?
1.
Negative 1. Okay. And then you guys get the idea here, so I'm just going to kind of crank through the rest of these now. Is that okay?
Yeah.
You've seen the idea. Now, many of us are probably looking at this and going, Mr. Kulik, I do not feel good about all this fraction crap that you've been doing here. That's making me real nervous. And I would say to you, student, remember before I showed you guys how to deal with those fractions with pi's in it on your calculator, right? We just type the problem in, leave off the pi's, have the calculator do it, get the fraction, put the pi back on it. If you have low fraction confidence, the calculator will clear that hurdle for you, right? Remember doing that?
Yeah.
In the last chapter I showed you, there's a fly in here and it's making me angry. I showed you guys how to do that, right? I missed him. All right. I want to point something else out to you. Look at those X's. Look at those X's. Do you notice anything? They're all fractions. Okay, look a little deeper. That's true.
They all have the same denominator.
They all have the same denominator, sure. What else? So did you see a pattern?
Yeah, they go up by 2.
They go up by 2 in the numerator, right? We started with -1, and then +1, and then 3, and 5, and 7. Mr. Kulik, will there always be a pattern in the X's? Yes. Will it always be 2? No. But there will always be a pattern. So, Mr. Kulik, are you telling me then, if I just figure out the first 2 points, can I just apply the pattern for the rest of the X's? Heck yeah, you can. Sure. Like if you just find the first 2 X's and notice, hey, that was 2 8s is all we're doing. Well, the next one is just adding 2 8s. So that's 3 8s, and then add 2 more 8s, 5 8s, and then 2 more 7 8s. Whoa! That's pretty cool. Right? Makes your life a little easier. Now, what's the risky part about just adding, like following the pattern? If you messed up the first 2 points, you would not catch that. So, at your own risk, I invite you to, again, you can use that shortcut, but there is some risk involved in it. All right, we have our points. What do we do now? We've got to plot them. So, I'm going to draw an XY axis. What scale should I use on the X? How much should a tick mark be? 2 pi? Well, pi over 8. You like that? So each tick mark is 1/8 of pi. So I can just count like 1, 2, 3, 4, 5, 6, 7 or whatever. I love that. Let's do that. My goodness, guys, come on now. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. I don't think I have enough to fit another set in that way. And if I look at my y's, my biggest y is 2. My smallest y is -4. I think just going by 1s on the y should do pretty nicely. Is everybody okay with how I built that out? Let's just say the directions ask you to graph from like -2 pi to +2 pi or something. Well, I have to say -pi to +2 pi because that's what I was able to fit in here. So far, so good? So let's plot the first point. That's -pi over 8. So that's 1 over -4. So 4 down. So I went 1 over and then 4 down. Plot my point. Everybody's okay? The next one is +pi over 8. So 1 over to the right, and then -1, so 1 down. And then we have 3 pi over 8 too, so we're going to go 3 over, and then 2 up, and then 5 over, and 1 down, and then 7 over, and 4 down. Everybody so far so good? Now, I still got to fill the rest of this space, though, because it asked me to graph all the way from -pi to +2 pi. Does that mean I'm going to have to generate more points? I'm not doing any more transformation. I'm just going to follow the pattern, right? So if I look at this first point, to get to the next one, I went over 2 and up 3, right? You guys see that? I went right 2 and up 3 to get to there. So I'm just going to start at this one. I'm going to go over 2 and up 3. And I'll do it again. Over 2, up 3. Now I'm at a maximum, so instead of going up 3, I'm just going to go down 3. So I'll go over 2, down 3, over 2, down 3, over 2, and then up 3. And I'll do the same thing in the reverse direction. So over 2, up 3, over 2, up 3, over 2, down 3, over 2, down 3. Oops. 3. So now I have points covering all the space that was, right? Everybody's cool? Now I'm just going to draw my graph to go through. So we'll just draw this to go through. Eight. Yes. All right. What do you guys think? Not too bad, right? Is it long? Yeah, kind of. But is like anything super duper difficult? Like algebraically, is this time? Basically, we're just plugging numbers in and like evaluating and then plotting points, right? Like, this is not the hardest thing I've ever done. One thing I will say about your graphing is I will be a little bit picky about what things look like. So neatness matters a little bit. In particular, one thing that I will for sure mark you down on is if you draw everything as a straight line and just draw it as a zigzag, I will mark you down for that. You have to have some attempt to curve your graph. It needs to have some curve to it. So no zigzags. Everybody's okay with what I mean? And then you really need to make sure you're plotting your points, and I can see your graph passing through the points. Those are the two things that I'm going to be certainly looking for, that you have the points in the right places, and then your graph goes through those points, and it's curvy and not zigzag straight line. You know what I mean? Okay. So, for this lesson, your assignment is this worksheet 1, the updated version. So in your content library, it says worksheet 1 updated. So on the first page, you're going to have just some trig equations, some functions, and ask you to find the amplitude, midline, period. Okay, that was easy. We've done that a bunch of times now. And frequency. Whoa, Mr. Kulik. I haven't heard this frequency word before. Are you trying to pull a fast one on me? That sounds like it might be hard. Just remind you, we go back to the notes from Friday. Here's frequency. What is 2 pi c, though, the same as? It's the period. So frequency is just 1 over the period. It's just the reciprocal. So if your period is 2 pi, what's your frequency? 1 over 2 pi. Oh my God, do you even really need a formula to do that? If you're finding the period anyway, just do the reciprocal afterwards. It's like nothing burger, right? Does everybody feel okay with that? Fantastic. All right, the other thing it asked you to do then is to list the transformations in order. So that's like the thing we did at the start. When I say in order, I mean do your C stuff, your A stuff, your H stuff, your K stuff, just like we did in our example. So in order means using the order that I gave you. Does everybody feel okay about this page on what to do? Okay. The next page is we're just going to be graphing things. So the AMPF here at front, at the top is amplitude, midline, period, frequency. So just writing that in. Everybody's okay there? And then off to the side, you'll create your transform points and then plot them and draw your graph. I encourage you to make sure you're looking at the scales. You're reading what the x and y axis are going by. So if I look at this problem, the y-axis goes by ones, right? So this is -2, -1, 0, 1, 2. Everybody see that? And if I look at the x-axis, we're going by, how far is a tick mark? What is this? Excellent. Pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, etc., right? So be careful when you're going to plot these things that you're looking at the axes. Like the next one, the y's changed. Oh no! Not a big deal though. Make sure you read them though. If I go down later, look, some of the x's changed, right? So just make sure you're paying attention to the scale before you start graphing things, just so you have them in the right place. Does that feel okay? So I think there's 6 of these graphs that you have to build on this homework sheet. Everybody's okay? All right. So let's review here what's due when. This Sunday, we have due the Delta Math, the Chapter 3 Delta Math. If you haven't finished, I think a lot of us have. I was looking the other day, and it seemed like a lot of us had a big chunk of that or all of it done. Worksheets 4 and 5, also due Sunday. This worksheet 1 updated, not due till the following Sunday, so like the 29th or something. Is everybody okay? What haven't we done yet for this chapter? Homework quiz. Boy, next week feels like a good time for a homework quiz. If you're caught up with your homework through graphing, you should be in good shape. So if you're comfortable with worksheets 4, 5, and the graphing, this chapter 1 updated, you should feel very confident for any homework quiz that might or might not happen next week. That was me like doing some winking. Just trying to be fun. Nobody laughs. You always take me so seriously. Ha! All right. Any questions about what we've done so far today? Questions on due dates? Okay. I'm going to be done talking. You should get something out to work on. We have approximately 30 minutes remaining in class. Work on your Delta Math. Work on your worksheets 4 and 5. Work on this new worksheet 1 updated. Find some math to be doing right now, please.